Welcome to Dreamly Sleep Space. I'm so glad you're here tonight. This is a place where curiosity meets calm, where the wonders of our world become a gentle path toward rest. Perhaps your day was full, perhaps your mind is still turning, or perhaps you simply love drifting off to the quiet voice of exploration. However you arrived, you're welcome here. Tonight's journey takes us into the Amazon rainforest, Earth's largest living system, a world of rivers that flow through the sky, trees older than civilizations, and life so abundant it defies imagination. You don't need to do anything but listen and let go. If these journeys help you find peace at the end of your day, consider subscribing to Dreamly Sleep Space. It helps others discover this quiet corner of the night. Now, let the forest call you in. The Amazon rainforest was not always here. Long before it became the verdant cathedral of life we know today, this region looked nothing like a rainforest at all. The story begins over 200 million years ago, when the continents were not scattered across the globe as they are now, but fused together in a single massive landmass called Pangaea. Within this ancient supercontinent, the land that would one day become South America lay pressed against what would become Africa, sharing a common geological past. Then, about 184 million years ago, something extraordinary happened. Deep beneath the surface, volcanic forces began to stir with unprecedented intensity. Massive plumes of magma rose from the Earth's mantle, pushing upward with such power that they fractured the very crust itself. Volcanoes erupted across vast stretches of Pangaea, spewing lava and gases, cracking the land into pieces. This volcanic fury was not a brief event, but a sustained period of geological violence that lasted for millions of years. Slowly, inevitably, the supercontinent began to break apart. The splitting of Pangaea set continents adrift on their tectonic plates, floating like immense rafts across the molten layer beneath. South America, separated from Africa, carried westward by the inexorable movement of the Earth's crust. As it drifted, the gap between the two landmasses widened, eventually becoming the Atlantic Ocean. This ocean grew broader over tens of millions of years, and as it did, it transformed the climate of the entire region. The expanding Atlantic brought moisture-laden winds from the east, trade winds that would eventually feed the rainforest with the water it needed to flourish. But the forest was not yet born. First, other forces had to shape the land itself. As South America moved westward, it collided with the Nazca tectonic plate, an oceanic plate sliding beneath the continent in a process called subduction. This collision was not gentle. The edge of the South American plate crumpled and buckled upward, folding rock layers like cloth pushed together on a table. Over millions of years, this relentless pressure raised an entirely new mountain range from the western edge of the continent. These were the Andes, destined to become one of the longest and highest mountain chains in the world, stretching over 7,000 kilometers from north to south. The rise of the Andes was crucial for the Amazon's future, for these mountains would act as a barrier, trapping moisture from the Atlantic and creating the conditions necessary for a rainforest to emerge. About 55 to 66 million years ago, during a period known as the Eocene, the climate of Earth was dramatically warmer than it is today. There were no ice caps at the poles, and tropical conditions extended far into what are now temperate regions. The Atlantic Ocean had widened sufficiently to deliver warm, moist air to South America, and the nascent Andes were beginning to rise, though they were not yet as tall as they would become. In this greenhouse world, forests began to spread across the continent, but these were not yet the rainforests we know. They were more open, dominated by ferns and conifers, with flowering plants only beginning to diversify. Then came a single event that changed everything. 66 million years ago, an asteroid, roughly 10 kilometers wide, slammed into the Yucatan Peninsula in what is now Mexico. The impact was catastrophic, releasing energy equivalent to billions of nuclear bombs. The collision vaporized rock, sent tsunamis crashing across coastlines, and threw so much debris into the atmosphere that sunlight was blocked for months, perhaps years. Fires raged across continents. Temperatures plummeted. The age of the dinosaurs ended in an instant of cosmic violence. But from this devastation, something remarkable emerged. The forests of the late Cretaceous period had been open canopy systems, with widely spaced trees and plenty of light reaching the forest floor. After the impact, as ecosystems slowly recovered over millions of years, flowering plants, the angiosperms, began to dominate. These plants had an advantage in the changed conditions. They grew faster, reproduced more efficiently, and could colonize disturbed ground more quickly than the older plant groups. Within a few million years, the forests of Amazonia transformed into dense, closed canopy systems with multiple layers of vegetation stacked atop one another. Sunlight had to fight its way through leaves and branches to reach the ground. The modern rainforest was beginning to take shape. Throughout the Cenozoic era, the period spanning the last 66 million years, the Amazon basin continued to evolve. Around 10 to 11 million years ago, another crucial transformation occurred. Before this time, the rivers that would become the Amazon flowed not eastward to the Atlantic, but westward toward the Pacific Ocean. The land was lower then, and water followed the gentlest slopes. But as the Andes continued to rise, they blocked the westward flow of rivers, creating an enormous inland sea, a vast freshwater lake that covered much of what is now the Amazon basin. This lake persisted for millions of years, filling the depression between the rising Andes to the west and the ancient shield rocks of the Guiana and Brazilian highlands to the north and south. Eventually, the lake found a new outlet. Waters began to work through weaknesses in the eastern highlands, carving channels toward the Atlantic. The Great Lake drained, and the Amazon River was born, flowing eastward in the direction it still follows today. This reversal of flow was one of the defining moments in the history of the region. With the river now carrying water from the Andes to the Atlantic, it brought with it enormous quantities of sediment, minerals, and nutrients eroded from the young mountains. These sediments enriched the lowland soils and created the conditions for an explosion of biodiversity. The climate, too, played a role. Over the past 2 million years, Earth has cycled through numerous ice ages, periods when glaciers advanced from the poles and temperatures dropped worldwide. During these colder, drier periods, the Amazon rainforest shrank. Savannas and drier woodlands expanded into regions that had been dense forest. The rainforest retreated into isolated pockets, refuges where rainfall remained sufficient to sustain the trees. In these refuges, species evolved in isolation, diverging from their relatives in other pockets. When the climate warmed again and the ice retreated, the rainforest expanded, and these isolated populations came back into contact, now different enough to be considered separate species. This cycle of contraction and expansion, repeated many times over hundreds of thousands of years, is thought to be one of the engines driving the Amazon's extraordinary biodiversity. Throughout these climatic shifts, the forest persisted. Even during the coldest and driest phases of the ice ages, the Amazon never entirely disappeared. It endured, shrinking and expanding like a living lung, breathing in time with the planet's climate. Each cycle added layers of complexity, new species, new relationships between organisms, new strategies for survival. By the time humans arrived in South America, perhaps 12 to 15,000 years ago, the Amazon rainforest had been growing, changing, and evolving for tens of millions of years. It was already ancient, already complex beyond comprehension, already home to more forms of life than any other terrestrial ecosystem on Earth. And it was still growing. Even today, the Amazon is not a finished product. It continues to gather material from the atmosphere, from the rivers that feed it, from the slow collapse and recycling of its own vegetation. Dwarf galaxies of smaller forests are absorbed into its vastness. Gas from the atmosphere becomes wood and leaf. Water rises from roots and returns as rain. The Amazon is not a place frozen in time. It is a process, an ongoing conversation between geology, climate, water, and life, written across millions of years and countless generations of living things. To understand the Amazon is to understand that nothing about it is simple or static. It is a forest built by time itself. The Amazon rainforest is not a single uniform blanket of green. It is a layered world, a vertical architecture of life, stacked from the soil to the sky. Each layer inhabited by different communities of plants and animals, each with its own microclimate, its own rhythms of light and shadow. To walk through the Amazon is to move through these layers, from the dark, humid forest floor upward through realms of increasing light and decreasing moisture, until finally breaking through into the brilliant, wind-swept canopy where the forest meets the open air. At ground level, the forest floor is a place of deep shade and stillness. Only about 2% of the sunlight that strikes the canopy above ever reaches the ground. In this perpetual twilight, the air is humid and still, heavy with the scent of decay. The soil itself is surprisingly poor, thin and acidic, leached of nutrients by millions of years of rain. What richness exists is locked not in the ground, but in the layer of decomposing leaves, branches, and organic matter that carpets the surface. This layer, the duff, is where the forest recycles itself. Fungi, bacteria, insects, and other decomposers work constantly to break down fallen material, releasing nutrients that are quickly absorbed by the shallow roots of trees before the rain can wash them away. In a rainforest, almost nothing is wasted. Death becomes life again within days. The understory rises above the forest floor, a realm of shrubs, saplings, and young trees waiting for their chance to grow. Light here is still scarce, and plants have adapted to make the most of what little reaches them. Leaves in the understory are often larger and darker than those higher up, maximizing their surface area to capture every photon. Some plants have developed drip tips, elongated points at the ends of their leaves that allow water to run off quickly, preventing the growth of mosses and algae that would block precious light. Life in the understory is a waiting game. Young trees can remain here for decades, growing slowly, biding their time until a storm or old age topples a giant above them and sunlight suddenly floods down through the gap. Then the race begins, a frantic competition among dozens of saplings to grow fastest and claim the newly opened space in the canopy. Above the understory lies the midstory, a transitional zone where trees are taller but still shaded by the giants above. Here, lianas begin to appear in greater numbers. These are woody vines that germinate on the forest floor but do not support themselves. Instead, they use trees as scaffolding, climbing upward toward the light by wrapping around trunks, hanging from branches, or anchoring themselves with tendrils. Some lianas grow so thick they resemble tree trunks themselves, creating tangled highways through the forest that allow animals to move from tree to tree without ever touching the ground. Birds, monkeys, and even jaguars use these aerial pathways, traveling through a three-dimensional maze that exists entirely above the forest floor. Then comes the canopy, the kingdom of light. This is where most of the forest's life resides, a continuous roof of leaves and branches stretching as far as the eye can see. The canopy is not smooth. It rises and falls in waves, punctuated by the crowns of emergent trees that push even higher, their tops protruding above the general level of the forest. These emergents can reach 60 meters or more, towering over everything else, exposed to full sun, wind, and rain. They are the giants of the forest, individuals that may be hundreds of years old, survivors of storms and lightning strikes, witnesses to centuries of change below. Life in the canopy is intense. Sunlight pours down without obstruction, and temperatures can be 10 degrees warmer here than on the forest floor. The air is drier, and the wind, which never penetrates to the ground, rustles leaves and sways branches. Plants here do not struggle for light. They bask in it, growing rapidly, flowering and fruiting in abundance. The canopy is a garden in the sky, home to orchids, bromeliads, ferns, and countless other epiphytes, plants that grow not in soil but on the branches of trees, drawing moisture and nutrients from rain and organic debris that collects in the nooks and crannies of bark. Some of these epiphytes hold small pools of water in their leaf bases, creating miniature aquatic habitats where frogs lay eggs, mosquito larvae develop, and entire food webs exist in volumes of water no larger than a coffee cup. The animals of the canopy are legion. Howler monkeys call to each other at dawn, their voices carrying for kilometers. Spider monkeys swing through branches with casual grace, their prehensile tails acting as a fifth limb. Sloths hang motionless, their fur tinted green by algae that grows in the grooves of each hair, camouflaging them among the leaves. Toucans, macaws, and parrots flash through the air in bursts of color, their harsh cries echoing above the hum of insects. Butterflies as large as birds float lazily from flower to flower, and beneath it all, hidden among leaves and bark, are the insects, millions upon millions of them, from leafcutter ants carrying pieces of foliage back to their underground gardens to beetles so large and armored they look like they belong in a science fiction film. The structure of the rainforest creates its own climate. The dense layers of vegetation act as insulation, trapping moisture and moderating temperature. During the day, the canopy absorbs sunlight and heats up, but much of that heat is used to evaporate water from leaves through a process called transpiration. Billions of tiny pores on the underside of leaves, called stomata, open and close, releasing water vapor into the air. A single large tree can transpire hundreds of liters of water each day. With hundreds of billions of trees in the Amazon, the volume of water released into the atmosphere is staggering, more than the river itself carries to the sea. This water does not simply disappear. It rises into the air, cools, and condenses into clouds, which then release the water again as rain. Much of the rain that falls on the Amazon is not from the Atlantic Ocean at all, but from the forest itself, recycled again and again in an endless loop. This ability to generate its own rain is what makes the Amazon resilient. Even during dry seasons, the forest continues to produce moisture, preventing the region from drying out completely. The trees create the conditions they need to survive, pumping water from deep in the soil, up through their trunks, and out into the air, where it becomes the rain that keeps the forest alive. It is a self-sustaining system, a vast, green machine that regulates its own environment, but it is also fragile. If too many trees are removed, if the canopy is opened and the soil exposed to direct sunlight, the cycle can break. Less transpiration means less rain. Less rain means fewer trees can survive. Fewer trees mean even less rain. The system can spiral downward, a feedback loop that could potentially transform rainforest into savanna, a shift that scientists fear may be approaching in some regions if deforestation continues. For now, though, the forest remains. The layers rise one above the other, each supporting the next, each dependent on the whole. From the dark, silent floor to the bright, noisy canopy, the Amazon is a vertical world, a living architecture built by evolution and sustained by water, light, and the ceaseless recycling of nutrients through a system older than human civilization. It is a structure so complex that we have only begun to understand how it works, and so beautiful that even in its smallest details, it invites wonder. The Amazon is a forest, yes, but it is also a river, or rather, a network of rivers so vast and intricate that it defies easy description. At the heart of this network flows the Amazon River itself, the second longest river on Earth, and by far the largest in terms of water volume. Every second, the Amazon discharges roughly 200,000 cubic meters of water into the Atlantic Ocean, more than the next 7 largest rivers combined. This is not simply a river. It is a moving continent of fresh water, a liquid highway that drains an area covering nearly 7 million square kilometers, roughly 40% of South America. The Amazon River begins high in the Andes, in the cold, thin air of the Peruvian mountains, less than 200 kilometers from the Pacific Ocean. Its source, a small stream called Apacheta Creek on the slopes of Mount Mismi, is so far from the sea that a drop of water falling here will take months to reach the Atlantic, traveling through one of the most complex and biologically rich landscapes on the planet. From this high, barren origin, the water descends rapidly, tumbling down steep slopes, joining with other streams, carving valleys through ancient rock. These headwater streams are clear and cold, fed by glaciers and snowmelt, carrying the minerals and sediments eroded from the mountains. As the rivers descend from the Andes, they slow and widen, merging into larger tributaries that flow across the vast lowlands of the Amazon basin. Here, the gradient is so gentle that the river meanders wildly, carving oxbow lakes and shifting its course over centuries. The water, once clear, becomes laden with silt, turning a milky brown color that gives these rivers their name. Whitewater rivers, the Madeira, the Purus, the Juruá, the Ucayali. These rivers and dozens of others flow eastward, carrying the wealth of the Andes toward the sea. The sediment they transport is not just dirt, it is nutrients, minerals, phosphorus, calcium, magnesium, the building blocks of life that will enrich the floodplains and sustain the forests and fields that line the riverbanks. Not all Amazonian rivers are whitewater. Some, like the Rio Negro, are blackwater rivers, stained dark by tannins and organic acids leached from decomposing vegetation. These rivers rise not in the mountains but in the lowland forests themselves, draining areas where the soil is ancient and nutrient-poor. The water of blackwater rivers is almost tea-colored, acidic and clear when you dip a cup into it, but appearing black when seen in depth. Because they carry little sediment, blackwater rivers do not build floodplains the way whitewater rivers do. Their banks are often steep, and the water itself supports fewer fish and other aquatic life. Yet they are no less important. The Rio Negro is one of the largest tributaries of the Amazon, and where it meets the main stem of the river, at Manaus, the two waters flow, side by side for several kilometers without mixing, a striking boundary of brown and black that eventually blurs and disappears downstream. Then there are the clearwater rivers, like the Tapajós and Xingu, which rise from ancient crystalline rocks of the Brazilian and Guiana highlands. These rivers are clear and blue-green, with sandy bottoms visible even in deep water. They carry little sediment because the rocks they drain are old and hard, resistant to erosion. The water is low in nutrients, but beautifully transparent, flowing over rapids and waterfalls that make them among the most visually stunning rivers in the world. The Amazon and its tributaries do not simply flow in fixed channels. Every year, the rivers rise and fall in a massive seasonal cycle driven by rainfall. During the rainy season, which varies across the basin but generally peaks between December and May, water levels can rise by 10 to 15 meters. Entire forests flood, becoming aquatic ecosystems where fish swim among the trees and river dolphins chase prey through submerged vegetation. These flooded forests, called várzea, are among the most productive habitats in the Amazon. The floodwaters bring nutrients from upstream, fertilizing the soil and feeding the roots of trees. Fish that normally live in the river move into the forest to feed on fruits and seeds that fall into the water, and in turn, these fish become prey for birds, caimans, and jaguars that hunt at the water's edge. When the waters recede during the dry season, they leave behind a layer of nutrient-rich sediment that makes várzea soils some of the most fertile in the Amazon. Unlike the poor soils of the upland forests, várzea soils can support agriculture without the need for slash and burn techniques. For thousands of years, indigenous peoples have lived along these floodplains, cultivating crops during the dry season and moving to higher ground when the waters return. The rhythm of the river dictates the rhythm of life. But the Amazon's water cycle extends far beyond the river itself. Much of the moisture that sustains the rainforest never touches the ground as liquid. It moves through the atmosphere, invisible rivers of vapor that flow westward from the Atlantic Ocean and then recycle within the forest itself. These aerial rivers, sometimes called flying rivers, are as important to the Amazon as the liquid water that flows in the channels below. The process begins over the Atlantic, where trade winds blow westward, carrying moist air over South America. As this air moves inland, it encounters the rainforest. The trees, through transpiration, pump additional water vapor into the atmosphere, adding to the moisture already present. This humid air rises, cools, and forms clouds, which release rain. Much of this rain falls back onto the forest, where it is absorbed by roots, pulled up through trunks, and released again from leaves as vapor. The cycle repeats. The same water molecules may be lifted and dropped multiple times as they move westward across the basin, recycled by the forest itself. In this way, the Amazon generates much of its own rainfall, creating a self-sustaining hydrological system that is largely independent of distant ocean currents. Eventually, the aerial rivers reach the Andes, where the moist air is forced upward by the mountains. As it rises, it cools further and releases the last of its moisture as rain or snow on the high peaks. This precipitation feeds the glaciers and streams that are the headwaters of the Amazon River. In a sense, the story comes full circle. Water that began as ocean spray over the Atlantic falls as rain in the forest, is transpired back into the air, drifts westward, falls as snow in the Andes, melts and flows down as streams, joins the great river, and finally returns to the ocean, only to be lifted again by the sun and begin the journey once more. This interconnected system of liquid and aerial rivers is what makes the Amazon a hydrological powerhouse. The forest is not merely shaped by water, it is a part of the water cycle itself, an active participant that influences rainfall patterns not only in South America, but across the entire continent. The moisture transported by these aerial rivers travels south, nourishing regions as far away as Argentina and southern Brazil. Without the Amazon's transpiration, these areas would be drier, less able to support the agriculture and populations they sustain today. The rivers of the Amazon are also highways. For millennia, they have been the primary means of travel through the region. Long before roads or airstrips, indigenous peoples used canoes to move through the basin, following the network of waterways that connect distant communities. Fish migrate up and down these rivers, some traveling thousands of kilometers to spawn. Pink river dolphins, found nowhere else on Earth, navigate murky waters using echolocation, hunting for fish in the tangled roots and submerged branches of flooded forests. Giant river otters, sleek and social, patrol stretches of river in family groups, their whistles and chirps echoing across the water. Even the smallest tributaries teem with life. Streams too narrow to paddle a canoe hold fish so specialized they exist only in a single creek or a single stretch of rapids. Frogs lay eggs on leaves overhanging the water, and when the tadpoles hatch, they drop into the stream below. Caimans, smaller relatives of alligators, bask on sandy banks, their eyes just above the waterline, waiting for prey. The rivers are arteries, feeding the forest and the creatures within it, carrying nutrients, sediments, and life itself from the mountains to the sea. The Amazon River system is not a simple feature of the landscape. It is the landscape, a living, flowing, constantly changing network that shapes and is shaped by everything around it. Without the rivers, there would be no rainforest. Without the rainforest, the rivers would be diminished, reduced to a fraction of their current flow. Together, they form a single integrated system, a union of water, soil, vegetation, and air that has persisted for millions of years and continues to sustain one of the most biodiverse regions on Earth. The Amazon rainforest is a botanical universe, a living library of plant life that contains more species in a single hectare than exist in many entire countries. Estimates suggest there are at least 40,000 plant species in the Amazon, and some scientists believe the true number may be far higher, with thousands of species yet to be discovered or formally described. These plants range from towering trees that reach 60 meters in height to tiny mosses and lichens that cling to bark in patches smaller than a coin. Each has evolved its own strategies for survival in a competitive, resource-limited environment where the struggle for light, water, and nutrients is constant and unforgiving. The trees of the Amazon are its most visible and defining feature. Over 16,000 tree species have been identified, more than exist in all of North America. Some of these trees are enormous, their trunks buttressed by massive flanges of wood that spread out from the base like the flying buttresses of a cathedral. These buttress roots are adaptations to the shallow, unstable soils of the rainforest. With most nutrients concentrated in the top few centimeters of soil, tree roots spread wide rather than deep, forming a shallow but extensive network. The buttresses help anchor the tree against wind and the weight of its own canopy, preventing it from toppling over. In the canopy, many trees produce flowers and fruits not at the ends of branches but directly on their trunks and main limbs. This phenomenon, called cauliflory, is an adaptation to attract specific pollinators. Bats, for instance, prefer to feed at locations they can easily access in flight, and flowers growing on trunks are more convenient than those hidden among foliage. Cacao, the tree from which chocolate is made, is a cauliflorous species, its pods growing directly from the trunk in clusters of deep purple or golden yellow. When a pod is opened, it reveals rows of seeds embedded in sweet, tangy white pulp, a treat for animals and humans alike. The diversity of tree species in any given area of the Amazon is staggering. A single hectare of forest may contain over 300 different species of trees, many of them represented by just one or two individuals. This extreme diversity makes the Amazon unusual among forests. In a temperate forest, a single species often dominates, with vast stands of oak, pine, or beech covering the landscape. In the Amazon, dominance is rare. Trees of the same species may be separated by hundreds of meters, scattered seemingly at random among a bewildering mix of other species. This spacing may be a defense against pests and diseases. If individuals of the same species are far apart, it is harder for specialized herbivores or pathogens to spread from one tree to another. But trees are only part of the story. Lianas, those woody vines that festoon the canopy, play a crucial role in the structure and dynamics of the forest. Some lianas can grow over 100 meters long, connecting dozens of trees in tangled webs. When a tree falls, it often brings down several others, held fast by the vines that link them. This creates large gaps in the canopy, openings where sunlight floods in and triggers a burst of growth. Lianas themselves compete fiercely for light. Unlike trees, which must invest in thick trunks to support their weight, lianas use other plants for support, allowing them to allocate more resources to leaves and growth. In some areas of the Amazon, lianas are becoming more common, possibly in response to increased carbon dioxide in the atmosphere, which favors their fast-growing, opportunistic lifestyle. Epiphytes are another defining feature of Amazonian plant life. These are plants that grow on other plants, using them as platforms to reach the light. Orchids are perhaps the most famous epiphytes, with thousands of species in the Amazon, each adapted to specific conditions of humidity, light, and temperature. Some orchids have bulbous stems called pseudobulbs that store water and nutrients, allowing them to survive dry spells. Others have aerial roots that dangle in the air, absorbing moisture from rain and mist. The flowers of rainforest orchids are often stunningly beautiful, shaped to attract specific pollinators. Some mimic the appearance and scent of female insects, tricking males into attempting to mate with the flower and inadvertently carrying pollen from one bloom to another. Bromeliads, relatives of the pineapple, are also common epiphytes. Their leaves form tight rosettes that collect rainwater, creating tiny pools in the canopy. These bromeliad tanks are miniature ecosystems, home to mosquito larvae, tree frogs, and even small crabs. Some frogs spend their entire lives in bromeliads, laying eggs in the water pools and raising their tadpoles without ever descending to the ground. The plants benefit from this arrangement as well. The waste products of the frogs and insects provide nutrients that the bromeliad absorbs through its leaves. Beneath the trees and vines, the forest floor is covered with a carpet of ferns, herbs, and seedlings. Some plants have evolved to thrive in the deep shade, developing leaves so efficient at capturing light that they can photosynthesize in conditions where only a fraction of a percent of sunlight penetrates. Others have given up on photosynthesis altogether. Parasitic plants, like the Rafflesia, live entirely on nutrients stolen from their host. Rafflesia produces the largest flower in the world, a fleshy, reddish bloom that can be a meter across and smells like rotting meat, attracting carrion flies that pollinate it. Many plants in the Amazon produce chemical defenses to deter herbivores. Alkaloids, tannins, and other compounds make leaves bitter or toxic, protecting them from being eaten. Some trees produce compounds so potent that indigenous peoples have used them as poisons for hunting. Curare, a plant-derived toxin, paralyzes muscles and has been used for centuries to tip blowgun darts. Other plants produce latex, a milky sap that gums up the mouthparts of insects or makes leaves unpalatable. The rubber tree, native to the Amazon, produces latex in such abundance that it became the basis of a global industry in the 19th and early 20th centuries, bringing wealth and exploitation to the region in equal measure. Yet for all their defenses, plants are not invincible. Leafcutter ants are among the most successful herbivores in the Amazon, harvesting enormous quantities of leaves and carrying them back to underground nests. But the ants do not eat the leaves. Instead, they chew them into a pulp and use it as compost to grow fungus, which they then consume. The relationship between ants and fungus is so close that neither can survive without the other. The ants farm the fungus, tending it carefully, removing contaminants, and even treating it with antibiotics produced by bacteria that live on their bodies. It is agriculture, practiced not by humans but by insects, a system that has been refined over millions of years. Plants in the Amazon have also evolved intricate relationships with animals for pollination and seed dispersal. Many trees rely on specific species of bats, birds, or insects to carry pollen from flower to flower. Some flowers open only at night, releasing powerful scents to attract nocturnal pollinators. Others are shaped to fit the beak or tongue of a particular bird species, ensuring that only the right pollinator can access the nectar inside. In return, the plant provides food, a mutualistic exchange that benefits both parties. Seed dispersal is equally specialized. Some trees produce fruits that are eaten by monkeys, birds, or tapirs. The animals digest the flesh of the fruit but pass the seeds unharmed, often depositing them far from the parent tree in a pile of nutrient-rich feces that helps the seed germinate. Other plants have evolved explosive fruits that burst open when ripe, flinging seeds several meters away. Still others produce seeds with hooks or barbs that catch on the fur of passing animals, hitching a ride to new locations. The botanical diversity of the Amazon is not random. It is the product of millions of years of evolution, shaped by competition, predation, climate, and geology. Each plant is a solution to the problem of survival in a world of limited resources and endless threats. Together, these plants form the foundation of the rainforest ecosystem, the primary producers that capture energy from the sun and transform it into the organic matter that feeds everything else. Without them, the forest would not exist. With them, it is the most complex and productive terrestrial ecosystem on the planet, a green cathedral built by countless species, each playing its part in the great unfolding story of life. The animal life of the Amazon is as diverse and intricate as the forest itself, a dazzling array of creatures that occupy every niche from the soil to the treetops. Scientists estimate that the rainforest is home to 10% of all known species on Earth, including over 400 species of mammals, 1,300 species of birds, 378 species of reptiles, more than 400 species of amphibians, and at least 2,500 species of fish. These numbers are almost certainly underestimates. New species are discovered every year, and vast stretches of the forest remain unexplored. The true number of species may be far higher, especially when insects are considered. Some estimates suggest that a single tree in the Amazon can host over 400 species of insects, many of them found nowhere else. Among the mammals, jaguars reign as the apex predators. These powerful cats are the largest carnivores in the Americas, capable of taking down prey as large as tapirs or caimans. Jaguars are solitary and elusive, moving through the forest and along riverbanks with a grace that belies their size. Their jaws are the strongest of any cat relative to body size, powerful enough to crush the skull of prey or pierce the thick shell of a turtle. Unlike most big cats, jaguars are excellent swimmers and often hunt in and around water, ambushing caimans or catching fish in shallow streams. Their fur, a golden yellow marked with black rosettes, provides camouflage in the dappled light of the forest, making them nearly invisible as they stalk their prey. In the canopy, monkeys are among the most visible and vocal animals. Howler monkeys announce their presence every dawn with calls so loud they can be heard for kilometers. These calls serve to establish territory, warning other groups to keep their distance. Spider monkeys, with their long limbs and prehensile tails, swing through the trees with acrobatic ease, covering large distances in search of fruit. Capuchin monkeys, smaller and more curious, use tools to crack open nuts and insects, displaying a level of intelligence rare among non-human primates. Watching a troop of capuchins move through the canopy is to witness a society in motion, complete with hierarchies, alliances, and squabbles. Sloths are perhaps the most unusual mammals of the rainforest. These slow-moving creatures spend almost their entire lives hanging upside down from branches, moving so little that algae grows on their fur, tinting it green and providing additional camouflage. Sloths descend to the forest floor only about once a week to defecate at the base of a tree. Why they do this, rather than simply relieving themselves from the canopy, is a mystery, but it may be related to nutrient cycling or to the moths that live in fife, sloth fur and lay eggs in the dung. Sloths are so slow that they are often mistaken for part of the tree itself, an excellent defense against predators that rely on movement to detect prey. Anteaters, both giant and tamandua species, wander the forest floor and lower branches, using their long, sticky tongues to extract ants and termites from nests. A single giant anteater can consume 30,000 insects in a day. Their claws are formidable, strong enough to tear open termite mounds and, if necessary, to defend against jaguars. Giant anteaters are solitary and mostly silent, moving through the forest like living shadows. Birds are everywhere in the Amazon, from the forest floor to the highest emergent trees. Harpy eagles, among the largest and most powerful raptors in the world, hunt monkeys and sloths in the canopy, their talons as large as a bear's claws. Toucans, with their enormous, colorful bills, feed on fruit and occasionally raid the nests of smaller birds. Macaws, brilliant in blue, red, and yellow, fly in pairs or small flocks, their raucous calls echoing through the forest. These birds mate for life, and their bond is reinforced through mutual grooming and synchronized flight. At certain times of year, macaws and other parrots gather at clay licks along riverbanks, eating the mineral-rich clay to neutralize toxins in the seeds and unripe fruits they consume. Hummingbirds, though tiny, are fierce competitors for nectar. Some species defend feeding territories aggressively, chasing away rivals with aerial displays that can involve flying backward, hovering, and even striking with their bills. Their wings beat so fast that they produce the characteristic hum that gives them their name. and their metabolism is so high that they must feed almost constantly during the day to avoid starvation. Reptiles thrive in the warm, humid climate of the Amazon. Anacondas, the heaviest snakes in the world, lurk in rivers and swamps, waiting to ambush prey that comes to drink. These constrictors can grow over 6 meters long and weigh more than 100 kilograms. They kill by wrapping around their prey and squeezing until the victim suffocates, then swallow it whole, unhinging their jaws to accommodate animals as large as capybaras or deer. After such a meal, an anaconda may not eat again for weeks or months. Caimans, relatives of alligators, are the dominant reptilian predators in Amazonian rivers. Black caimans, the largest species, can exceed 5 meters in length and pose a danger to any animal that ventures too close to the water, including humans. Spectacled caimans, smaller and more common, are often seen basking on riverbanks, their eyes just above the surface as they wait for fish or birds. Poison dart frogs, small and brilliantly colored, inhabit the leaf litter and understory vegetation. Their skin secretes toxins derived from the insects they eat, toxins potent enough that indigenous peoples have used them to poison blowgun darts for hunting. The bright colors of these frogs are a warning to predators, a signal that says, "Eat me and you will regret it." Some species are so toxic that simply touching them can cause numbness or pain. Fish in the Amazon are as diverse as the terrestrial animals. The river and its tributaries support over 2,500 species, more than any other river system on Earth. Piranhas, infamous for their sharp teeth and feeding frenzies, are often misunderstood. Most species are not the voracious man-eaters of popular imagination, but opportunistic feeders that eat fruit, seeds, and carrion as often as live prey. That said, some species can be aggressive, particularly when water levels are low and food is scarce. Electric eels, despite their name, are not true eels, but a type of knifefish. They can generate electrical discharges of up to 600 volts, enough to stun prey or deter predators. These discharges are produced by specialized cells called electrocytes, stacked like batteries along the eel's body. Electric eels use weak electrical pulses to navigate and locate prey in murky water, then deliver a powerful shock to immobilize it. Arapaima, one of the largest freshwater fish in the world, can grow over 3 meters long and weigh 200 kilograms. They breathe air, rising to the surface every few minutes to gulp oxygen, an adaptation to the low oxygen levels of stagnant floodplain waters. Indigenous peoples have hunted arapaima for centuries, and overfishing has made them rare in many areas, though conservation efforts are beginning to reverse the decline. Insects are the true masters of the Amazon, numbering in the millions of species. Leafcutter ants march in long columns, each carrying a piece of leaf like a sail, heading back to underground nests that can house millions of individuals. Army ants, nomadic and aggressive, sweep through the forest in massive raids, consuming any small animal unable to escape. Butterflies fill the air in clouds of color, some species with wingspans as wide as a human hand. Beetles come in every shape and size, from tiny jewel beetles that glitter like gemstones to rhinoceros beetles with horns longer than their bodies. Every animal in the Amazon is part of a web of relationships: predator and prey, parasite and host, pollinator and flower. Remove one strand and the web weakens. The forest is not a collection of isolated species, but a community, an interconnected system where the survival of each depends on the presence of others. It is this complexity, this interwoven richness, that makes the Amazon so extraordinary and so vulnerable. Long before Europeans arrived, long before nations drew borders and cities rose along the rivers, the Amazon was home to people. Indigenous peoples have lived in the rainforest for at least 12,000 years, and possibly much longer. They developed cultures as diverse as the forest itself, speaking hundreds of distinct languages, practicing different customs, worshipping different spirits, yet all sharing a deep connection to the land and the rivers that sustained them. To understand the Amazon is to understand that it is not a wilderness untouched by human hands. It is a cultural landscape shaped by millennia of human presence, management, and knowledge. When the first Europeans explored the Amazon in the 16th century, they were astonished by the densities of people they encountered along the rivers. Spanish explorer Francisco de Orellana, traveling down the river in 1542, reported passing through regions where villages lined the banks for days of travel, with populations numbering in the thousands. Later visitors confirmed these accounts, describing complex societies with agriculture, trade networks, and impressive earthworks. Some estimates suggest that as many as 8 to 10 million people lived in the Amazon basin before European contact, a number that rivals the populations of contemporary European cities. These peoples were not living in primitive simplicity. Archaeological evidence reveals that they transformed the landscape in profound ways. They created terra preta, or black earth, a type of soil enriched with charcoal, bone, and organic waste that remains fertile to this day, centuries after its creation. Terra preta is found across large areas of the Amazon, covering thousands of square kilometers. It was not a natural feature, but the result of deliberate soil management, a form of agriculture that allowed intensive cultivation without depleting the soil. In areas where terra preta exists, biodiversity is often higher, with groves of fruit trees and medicinal plants that descend from species cultivated by indigenous peoples long ago. Beyond terra preta, indigenous groups built large earthworks, including raised platforms, roads, canals, and geoglyphs. In the western Amazon, particularly in present-day Bolivia and Brazil, vast geometric shapes etched into the ground have been discovered beneath the forest. These geoglyphs, some covering several square kilometers, were created by removing soil to form patterns visible only from above. Their purpose remains unclear, whether ceremonial, astronomical, or practical, but their scale demonstrates a level of organization and labor that contradicts the idea of the Amazon as an empty, untouched wilderness. Indigenous peoples also practiced forest gardening, selectively planting and encouraging useful species while removing less desirable ones. Over time, this management created forests dominated by trees that provided food, medicine, or materials. The Brazil nut, the cacao tree, the rubber tree, all were cultivated and spread by indigenous peoples long before Europeans knew they existed. When scientists today find groves of these trees in seemingly wild forest, they are often looking at the legacy of ancient agriculture. Life in the Amazon varied depending on the environment. Along the fertile floodplains, where vasier soils supported abundant crops, populations were larger and more sedentary. These river-dwelling peoples cultivated manioc, maize, beans, squash, and a host of other crops. They fished with nets and traps, hunted with bows and blowguns tipped with poison, and built large communal houses from wood and palm thatch. Social structures were complex, with chiefs, shamans, and warriors playing distinct roles. Trade networks extended for hundreds of kilometers, with goods like salt, feathers, and stone tools moving between regions. In the upland forests, away from the rivers, life was more mobile. Groups practiced shifting cultivation, clearing small plots, burning the vegetation to release nutrients, and planting crops for a few years before moving on and allowing the forest to regrow. This system, often called slash and burn agriculture, is sustainable when land is abundant and populations low, as the forest regenerates naturally in the abandoned plots. However, when population pressure increases or land becomes scarce, the system can break down, leading to soil degradation and deforestation. The spiritual life of Amazonian peoples was deeply intertwined with the natural world. Shamans, spiritual leaders who mediated between the human and spirit realms, used plant medicines to enter trance states and communicate with the forces they believed governed health, weather, and fortune. Ayahuasca, a brew made from the ayahuasca vine and leaves of the chacruna plant, was and still is central to many spiritual practices. The brew contains compounds that alter consciousness, producing visions that shamans interpret as journeys into other worlds. These practices were not recreational but sacred, part of a cosmology that saw the forest as alive with spirits, where every tree, river, and animal possessed consciousness and agency. Indigenous peoples viewed themselves not as separate from nature, but as part of it. Rivers were not resources to be exploited, but living beings with their own needs and rights. Forests were not property, but communities to which humans belonged. This worldview shaped how they interacted with the environment, fostering a relationship of reciprocity and respect rather than domination. They took what they needed, but understood that overuse would lead to collapse, a lesson learned over countless generations. The arrival of Europeans shattered this world. Diseases brought by colonizers, smallpox, measles, influenza, swept through indigenous populations with devastating speed. Having no immunity to these illnesses, entire communities were wiped out within years. Some estimates suggest that up to 90% of the indigenous population died in the first century after contact. Villages were abandoned, fields overgrown, and the knowledge held by elders lost forever as entire cultures vanished. Those who survived faced enslavement, forced labor in rubber plantations, gold mines, and colonial estates. They were pushed off their lands, their children taken to be educated in European ways, their languages forbidden. The scars of this history are deep and still felt today. Yet against all odds, indigenous peoples endured. Today, over 1 million indigenous people live in the Amazon, representing 385 distinct ethnic groups. They continue to speak 274 different languages, each a repository of knowledge about the forest, its plants, its animals, its cycles and secrets. In recent decades, there has been growing recognition of the value of indigenous knowledge. Scientists now consult with indigenous communities to learn about medicinal plants, sustainable harvesting practices, and forest management. Many of the medicines used in modern pharmacology were first identified by indigenous peoples, who have spent millennia experimenting with plants to find cures for ailments. Quinine, used to treat malaria, comes from the bark of a tree native to the Amazon. Curare, once used only for hunting, is now employed as a muscle relaxant in surgery. Indigenous territories, when legally recognized and protected, are among the most effective bulwarks against deforestation. Studies have shown that forests within indigenous lands are better preserved than those in adjacent protected areas or private holdings. This is not because indigenous peoples are passive stewards, but because they actively manage the forest, preventing illegal logging, mining, and land grabbing. They patrol their territories, report infractions, and fight, sometimes at great personal risk, to defend their homes. Yet the threats are immense. Loggers, miners, ranchers, and land speculators continue to encroach on indigenous lands, often with the tacit or explicit support of governments more interested in short-term economic gain than long-term sustainability. Indigenous leaders who stand in the way of these interests face violence and intimidation. Many have been murdered for defending their territories, their deaths barely reported and rarely prosecuted. The story of the Amazon is inseparable from the story of its people. To protect the forest is to protect the rights and livelihoods of those who have lived there for millennia. To ignore them is to lose not only a vital cultural heritage, but also the knowledge and practices that could help us live more sustainably on this planet. The Amazon is not empty. It never was. It is home, and it always has been. The Amazon rainforest is more than a local or even regional ecosystem. It is a vital component of the Earth's climate system, a vast engine that influences weather patterns, regulates temperatures, and stores carbon on a scale that affects the entire planet. To understand the Amazon is to understand that what happens here matters everywhere. that the health of this forest is intimately connected to the stability of the global climate. One of the most important roles the Amazon plays is as a carbon sink, a natural system that absorbs more carbon dioxide from the atmosphere than it releases. Trees, through photosynthesis, take in carbon dioxide and use it to build their tissues. Wood, leaves, roots, all are made largely of carbon. A single large tree can store hundreds of kilograms of carbon over its lifetime. With an estimated 390 billion trees in the Amazon, the total amount of carbon stored in the forest is staggering, somewhere between 100 and 150 billion metric tons. This is equivalent to more than a decade of global carbon emissions from human activities. This carbon is not locked away forever. When trees die and decompose, or when they burn, the carbon is released back into the atmosphere as carbon dioxide. But in a healthy, stable rainforest, the uptake of carbon by growing trees roughly balances the release from decomposition and respiration. The forest neither adds to nor removes from the atmospheric carbon budget. It simply holds vast amounts of carbon in a stable form, preventing it from contributing to the greenhouse effect. However, recent research suggests this balance is shifting. Deforestation, fires, and the impacts of climate change are causing parts of the Amazon to release more carbon than they absorb, turning the forest from a carbon sink into a carbon source. If this trend continues, the implications for global climate are profound. The release of even a fraction of the carbon stored in the Amazon would accelerate warming, driving the planet toward more extreme climate scenarios. Some scientists fear that the Amazon is approaching a tipping point, a threshold beyond which the forest could rapidly transform into a savanna, releasing enormous quantities of carbon and permanently altering the climate of South America and beyond. The Amazon also plays a crucial role in regulating temperature, both locally and globally. The dense canopy of the forest absorbs vast amounts of solar energy, but much of this energy is used for evapotranspiration rather than heating the air. As water evaporates from leaves, it carries heat away, cooling the surface. This process keeps the temperature of the forest several degrees cooler than it would be if the land were cleared. Cleared land, especially if converted to pasture or farmland, absorbs more heat and radiates it back into the atmosphere, raising local temperatures and altering microclimates. The moisture released by the forest through evapotranspiration does not simply dissipate. It rises into the atmosphere, condenses into clouds, and falls as rain, not only over the Amazon, but over distant regions as well. The flying rivers of water vapor that flow westward from the Amazon influence rainfall patterns across much of South America. Studies have shown that moisture from the Amazon contributes to rainfall in southern Brazil, Paraguay, and Argentina, regions that are major agricultural producers. Without the Amazon's contribution to the hydrological cycle, these areas would be drier, with significant impacts on food production and water availability. The forest also influences global atmospheric circulation. By releasing enormous quantities of water vapor, the Amazon helps drive large-scale air currents that transport heat and moisture around the planet. Changes in the forest's extent or health can affect these currents, with potential consequences for weather patterns far from the Amazon itself. There is evidence, for instance, that deforestation in the Amazon can influence rainfall in North America and even the frequency of hurricanes in the Atlantic. The Amazon's role in oxygen production is often cited, with the forest sometimes called the lungs of the earth. This description is poetic but not entirely accurate. While it is true that the Amazon's trees produce vast amounts of oxygen through photosynthesis, they also consume oxygen through respiration, especially at night and during decomposition. The net contribution of the Amazon to atmospheric oxygen is close to zero, a balance between production and consumption. However, this does not diminish the forest's importance. The metaphor of lungs is apt not because of oxygen, but because of the forest's role in cycling carbon and water, processes that are essential for maintaining the planet's climate. Climate change is already affecting the Amazon. Rising temperatures and changes in rainfall patterns are altering the distribution of species, stressing trees, and increasing the frequency and intensity of droughts. During severe droughts, such as those in 2005, 2010, and 2015, tree mortality increases, rivers shrink, and the risk of fire rises. These fires are not natural. The Amazon is a wet environment, and fires are rare under normal conditions. But when the forest is dried out by drought and fragmented by deforestation, fire can spread quickly, consuming vast areas and releasing smoke that chokes cities thousands of kilometers away. The feedback loops are concerning. Deforestation reduces the forest's ability to generate rain, leading to drier conditions, which in turn make the remaining forest more vulnerable to fire. Fires release carbon, adding to the greenhouse effect and accelerating warming. Warmer temperatures and altered rainfall further stress the forest, creating conditions for more deforestation and fire. At some point, this feedback loop could become self-reinforcing, driving the Amazon toward a state from which it cannot recover. Preventing this requires urgent action. Protecting existing forests, reforesting degraded areas, and reducing global carbon emissions are all necessary steps. The Amazon cannot be saved in isolation. Its fate is tied to decisions made far from its borders, in boardrooms, legislatures, and homes around the world. Every ton of carbon emitted, every product purchased without regard for its environmental impact, every policy that prioritizes short-term profit over long-term sustainability contributes to the pressures on the Amazon. But there is also hope. The forest has survived for millions of years, enduring ice ages, droughts, and countless other challenges. Its resilience is remarkable. With proper protection and sustainable management, it can continue to thrive. Indigenous peoples have shown that it is possible to live in and from the forest without destroying it. Their example offers a path forward, a way to balance human needs with the health of the planet. The Amazon is not lost, not yet, but its future depends on choices made now, in this generation. The Amazon rainforest is not a static entity. It is a living system in constant motion, cycling nutrients, water, energy, and life itself through processes that have been refined over millions of years. To witness these cycles is to glimpse the inner workings of one of the most complex systems on Earth, a vast interconnected web where nothing is wasted and everything is transformed. At the heart of the forest's fertility is the nutrient cycle, the process by which essential elements move from soil to plant to animal and back again. In most ecosystems, nutrients are stored in the soil, slowly released by the weathering of rocks and the decomposition of organic matter. But in the Amazon, the soil is ancient and heavily leached by millions of years of rain. The nutrients that once resided in the soil have long since washed away, leaving behind a substrate that is often little more than sand and clay, acidic and poor. So where do the nutrients come from? The answer lies above ground. In the Amazon, most nutrients are locked not in the soil but in the living biomass, in the leaves, wood, and roots of plants and the bodies of animals. When a leaf falls, when an animal dies, decomposers go to work immediately. Fungi, bacteria, insects, and other organisms break down the organic matter, releasing nutrients in forms that plant roots can absorb. This happens so quickly that nutrients rarely have time to accumulate in the soil. Tree roots form shallow mats just below the surface, ready to capture nutrients the moment they are released. In this way, the forest recycles itself, maintaining fertility in an environment where the soil itself offers little. Mycorrhizal fungi play a crucial role in this process. These fungi form symbiotic relationships with tree roots, extending their filaments, called hyphae, deep into the soil. The fungi act as extensions of the root system, vastly increasing the surface area available for nutrient absorption. In exchange, the trees provide the fungi with sugars produced through photosynthesis. This partnership is so important that many trees cannot survive without their fungal partners. The mycorrhizal network also connects different trees, creating what some scientists have called the wood wide web, a hidden communication system through which trees can share nutrients and even chemical signals. Nitrogen, an essential nutrient for all living things, is particularly scarce in the Amazon. Most nitrogen is locked in the atmosphere as nitrogen gas, a form that plants cannot use. But certain bacteria, living in the soil or in nodules on the roots of leguminous plants, can convert atmospheric nitrogen into ammonia, a process called nitrogen fixation. This fixed nitrogen becomes available to plants, enriching the ecosystem. Legume trees, which host these bacteria, are thus keystone species in the forest, their presence boosting the growth of other plants around them. Water cycles through the forest in a rhythm dictated by the seasons. During the rainy season, water falls in torrents, sometimes more than a meter of rain in a few months. Rivers swell, floodplains inundate, and the forest becomes a waterlogged world where fish swim among the trees and caimans hunt in the shallows. Plants and animals have adapted to these conditions. Trees develop buttress roots and pneumatophores, specialized roots that stick up above the water to access oxygen. Fish time their reproduction to coincide with the floods, laying eggs in the newly submerged vegetation where food is abundant and predators fewer. During the dry season, the rains diminish, rivers shrink, and the forest floor dries out. Many trees drop their leaves, not because of cold as in temperate forests, but to conserve water. The fallen leaves form a thick layer of litter that insulates the soil and slows evaporation. Some animals, particularly fish, migrate to permanent water bodies, where they wait out the dry months in crowded pools. Others, like the lungfish, burrow into mud and enter a state of dormancy, breathing air through modified swim bladders until the rains return. Energy flows through the forest in a network of feeding relationships. At the base are the primary producers, the plants that capture sunlight and convert it into chemical energy through photosynthesis. Herbivores, from caterpillars to tapirs, feed on plants, transferring some of that energy up the food chain. Carnivores, from spiders to jaguars, feed on herbivores and in turn may be eaten by larger carnivores or parasites. At each step, energy is lost as heat, so that the top of the food chain supports far fewer individuals than the base. A single jaguar requires a vast territory to find enough prey, a reflection of the inefficiency of energy transfer through ecosystems. Decomposers and detritivores close the loop. They break down dead organic matter, releasing nutrients and energy back into the system. Without them, the forest would suffocate under its own waste, nutrients locked away in dead wood and leaf litter. Instead, decomposition is rapid, driven by the warm, moist conditions that favor microbial and fungal growth. A fallen tree may be reduced to humus in a matter of years, its substance dispersed through the soil and absorbed by new growth. Symbiosis is everywhere in the Amazon, relationships where two or more species interact to mutual benefit. Ants and acacia trees form one such partnership. The trees provide shelter in hollow thorns and food in the form of nectar and protein-rich nodules. In return, the ants defend the tree, attacking any herbivore or vine that tries to damage it. The relationship is so tight that neither species can survive without the other. Fig trees and fig wasps are another example. Each species of fig tree is pollinated by a specific species of wasp. The female wasp enters the fig through a tiny opening, laying eggs and pollinating flowers in the process. The wasp's larvae develop inside the fig, feeding on some of the seeds. When the wasps emerge, they carry pollen to other fig trees, continuing the cycle. Without the wasps, the figs could not reproduce. Without the figs, the wasps would have no place to lay eggs. The relationship is so ancient and so specific that it has co-evolved for millions of years. Predator-prey relationships also shape the forest. Predators keep herbivore populations in check, preventing any one species from overgrazing and degrading the vegetation. In areas where predators have been removed, herbivore populations explode, leading to overbrowsing and loss of plant diversity. The presence of top predators, like jaguars and harpy eagles, thus has cascading effects throughout the ecosystem, influencing the abundance and behavior of species at all levels. The Amazon is not a collection of isolated species, but a community, an interconnected whole where each organism is linked to many others. Change one part and the effects ripple outward, altering the entire system. This interconnectedness is what makes the Amazon so resilient, but also so vulnerable. The loss of a single species might seem insignificant, but if that species plays a key role, its disappearance can trigger a cascade of extinctions and disruptions. The forest is a web, and every strand matters. And now, as you rest, the forest continues its cycles. Trees draw water from the soil and release it into the air. Leaves fall and decompose, their nutrients absorbed by roots and transformed into new growth. Rivers rise and fall with the rhythm of the seasons. Animals hunt, feed, reproduce, and die, their bodies returning to the soil to nourish the next generation. The Amazon breathes, a slow, steady respiration that has sustained life for millions of years and will continue, we hope, for millions more. The story of the Amazon is not a story of stillness or simplicity. It is a story of motion, of transformation, of countless species interacting in ways we are only beginning to understand. It is a forest built by time, shaped by water and sunlight, inhabited by more life than exists in almost any other place on Earth. It is a forest that gives rain to continents, that stores carbon equal to a decade of human emissions, that holds secrets and medicines we have yet to discover. You are part of this story. The oxygen you breathe, the water you drink, the climate that makes your home habitable, all are influenced by this forest. The choices you make, the products you buy, the policies you support, ripple outward, touching even this remote and ancient place. The Amazon is not somewhere else. It is here, in the air you breathe, in the rhythm of the seasons, in the stability of the climate. Its fate is tied to yours. But the Amazon is more than its role in global systems. It is a place of beauty, of mystery, of wonder. It is the call of a howler monkey echoing through the dawn. It is the shimmer of a butterfly's wing catching the light. It is the cool, dark quiet of the forest floor and the blinding brightness of the canopy. It is the sound of rain on leaves, the smell of wet earth, the touch of mist rising from a river at sunrise. It is a place where life flourishes in forms beyond counting, where every tree, every insect, every drop of water is part of a story older than human memory. Tonight, as you drift towards sleep, imagine yourself beneath the canopy, resting on soft moss, listening to the sounds of the forest, the hum of insects, the rustle of leaves, the distant call of a bird. Around you, the forest is alive, breathing, growing, cycling energy and nutrients through its vast body. You are safe here, cradled by a system that has endured for millions of years, a system that asks only to be allowed to continue, to thrive, to be. If you enjoyed this journey through the Amazon, consider subscribing to Dreamly Sleep Space. Each episode invites you to explore the wonders of our world, to learn, to rest, and to find peace beneath the quiet stars. Sleep well and dream of green cathedrals, of rivers in the sky, of forests that breathe with the rhythm of the earth.